Statics practice problems. Okay. First one. Simplest one. This can actually be done with center of gravity as much and just torque as much as anything else. So here we go. It's going to be this problem 2. Depending on which class you're taking with me, could end up being a different number. But what we have is a beam being carried by 2 people. A uniform beam of length 7.6 meters and weight 450 newtons is carried by 2 workers, Sam and Joe. Determine the force each person exerts on the beam. Alright, so we need to sketch out the beam. Come to think of it, I should just use the square tool. That's nice and easy. Let's see. First person is a distance 1.00 meters in. The whole thing is 7.60 meters long. We've got the first person doing their thing, and then the other one is 2.0 meters from the other end. And they're also holding the beam and moving along. Alright, it did say it is uniform, and the weight is 450 newtons. Okay, first thing we should think about, what does uniform mean? Uniform means the density is the same everywhere. If the density is the same everywhere, that means the center is the center of mass. So thinking about that, the center of mass is therefore half of 7.6. Half of 7 is 3.5. Half of 0.6 is 0.3. So 3.5, 3.8. 3.80 meters from one of the ends. Alright, why do we care? Well, we need to know where the forces are. So we've got, oops, pointed it the wrong way. Force due to Joe on this end. Sorry, force due to Sam on this end, and force due to Joe on the other. Then we have the gravitational force, the weight acting at the center of mass. Okay, to solve this problem, we will need to think about the sum of forces. So force of Joe plus force of Sam minus the weight will be equal to 0. We don't want it moving up and down. We don't want it accelerating. So that's our sum of forces bit. Sum of torques. This is where things get interesting. There are 3 possible logical choices for where you put the center of rotation. You can put it at Sam. You can put it at the center of mass. You can put it at Joe. You could actually put it literally anywhere you want in this picture, but we need to pick one to find our sum of torques. It doesn't matter where you put it. You'll get the same result no matter where you put it. There are best choices, however. So for instance, I'm going to find out the force due to Joe first. So I'm going to set this at Sam. That means the torque due to Sam is going to be a whole lot of nothing because the distance to it is now 0. Then we need to think about the distance from Sam to the center. That's going to be half of the distance is 3.8 minus 1. It'll be 2.80 meters. On the other side of things, the distance from Sam to Joe is going to be 7.6 meters minus 1 minus 2. So 7.6 minus 1 is 6.6 minus 2 is 4.60 meters. Alright, let's do the center of mass next. Coming out to it, curling down, it's a clockwise rotation, so this would be a minus the 2.80 meters times W. On the other hand, if we come out to Joe and turn up, that's going to give us a positive. So we have 4.60 meters times force of Joe. We need the torques to sum to 0. We don't want it tilting. So that gives us what we need. Alright, so if we rearrange this, it's going to be 2.80 meters times W divided by 4.60 meters, and that will give us force of Joe. I did do both steps of algebraic rearrangement at once. You move the negative 2.80 meters W to the other side, then you divide through by the 4.6. So this will be 2.80 meters times 450 newtons divided by 4.60 meters. All right, 2.8 times 450 divided by 4.6. And that means the force of Joe is 274 newtons. Okay, the next one is useful once we have that. Fs would be equal to W minus F Joe, so Sam's force. 450 minus our previous answer will give us 176 newtons. So here's an interesting thing to observe. If you're ever having to gang carry something, make sure you hold it near an end so you don't have to exert as much force. No, just make sure that you kind of carry it evenly. Because notice the person who's closer to the center of mass is having to carry more of the load. That's a general result. That actually happens all the time. So keep that in mind when you are dealing with problems like this. Whoever is closer to the center of mass, or whatever is closer to center of mass, will generally end up supporting more of the weight of the thing. All right, that was a simple one-dimensional problem involving kind of center of gravity and statics. The problems kind of build up from here. The next one's going to be a classic. We're going to talk about ladders. All right,